Hello everyone, and a very warm welcome to KognitoKey. I'm so glad you're here. Have you ever really thought about the hidden split-second danger that kicks off the exact moment you power on your electronics? I mean, there is literally a tiny invisible war happening inside your devices every single time you hit that switch. Today, we're demystifying the brilliant little component that saves your gear from complete and utter destruction. Let's dive right in.
So, what actually happens in that exact split second you turn a power supply on? Well, imagine a device that's been sitting switched off for a while. Inside, its internal capacitor is completely empty, totally uncharged. When you flip that switch to on, that uncharged capacitor behaves exactly like a dead short circuit. It instantly demands this massive, unrestricted rush of electricity to fill up. It's honestly like trying to drink from a fire hose.
In the electronics world, we call this sudden rush a surge current. It is a highly destructive peak current that flows during that initial charging process. And what's truly alarming here is just how high this current gets, purely because there is virtually zero resistance in its path. The only natural resistance slowing things down comes from the diode's bulk resistance and the transformer windings. Without some kind of intervention, this surge can easily cause devastating overheating, literally melting down your circuit elements before you even realize what's happening.
Now, to stop our expensive electronics from just going up in smoke, engineers typically rely on one of two standard workarounds. Fix number one is installing heavy-duty diodes. These are rugged components with incredibly high current ratings that can safely take the hit of those massive peak voltages. Fix number two, using small, low-capacity capacitors. Because they are so incredibly small, they charge up almost instantly. The surge still happens, sure, but it's over so fast it simply doesn't have the time to overheat the circuit.
But that begs the question, right? What exactly counts as a small capacitor? Well, 1,000 microfarads is pretty much the critical threshold here. If your capacitor is under this mark, the surge is practically instantaneous and totally harmless. But the moment you go larger than 1,000 microfarads, the charging naturally takes longer. And when it takes longer, that massive surge current turns into a dominating, highly destructive force.
And this brings us to a really tricky engineering dilemma. What if your specific application absolutely requires a massive capacitor? I mean, heavy-duty power supplies strictly depend on them. And what if you simply do not have adequate high-rating diodes available to absorb that massive hit? Well, your circuit is essentially sitting there totally unprotected and highly vulnerable to that devastating initial surge.
Enter the absolute hero of our story today, the surge protector, or as it's commonly known, the surge resistor. This is a very specific resistor strategically inserted right between the rectifier circuit and the filter circuit. Its sole purpose in life is to provide a life-saving block of impedance precisely during that initial excessive current flow. It steps in exactly when the circuit is at its most vulnerable, gently taming that wild rush of electricity.
If we map out the electrical flow chronologically, you can see exactly how brilliant this is. First, the step-down transformer lowers the supply voltage. Next, the bridge rectifier converts that into pulsating DC. And then, right at step 3, the surge protector intercepts this pulsating DC. It stands there like a guard at the gate, absorbing the absolute brunt of the surge, right before the electricity can hit the highly vulnerable capacitor filter in step 4. It's just a beautifully simple yet profoundly effective setup.
So where do these hidden heroes actually live? While you might skip them in everyday low-power circuits, they have some absolute non-negotiable applications. They are heavily used in large power supplies. They are a strict necessity for any circuit requiring capacitors over that 1,000 microfarad rule we talked about. And they are essential when heavy-duty diodes just aren't an option. They play a truly vital role in bringing that dangerous surge current down to a perfectly safe, manageable value.
Let's wrap this explainer up with a powerful summary straight from our source. It minimizes its effect, providing impedance during excessive current flow. The next time you switch on a heavy-duty device, I want you to picture this invisible protector quietly saving your electronics from completely destroying themselves from the inside out. It really makes you wonder, doesn't it? If a tiny resistor can save a massive power supply, what other hidden heroes are keeping our digital world alive? Thank you so much for joining me today. If you enjoyed this explainer, please subscribe to the KognitoKey channel, and definitely make sure to like and share this video. Until next time, keep learning and stay curious.